There are advantages and disadvantages in talking after lunch, because so the advantages are that half the audience is asleep and you could pretty much tell anything you want. The disadvantage is that people who are not asleep are usually in the front row and they ask a lot of questions that are unpleasant. But there's another advantage. All the people who talked before me introduced a lot of concepts that have very strong relevance to what we are doing. Basically, they describe the technological components that enable us to build our bot detection system. Well, let's see. Does it work? Remember the good old days? Anybody recognizes this? Okay. Anybody doesn't recognize what it is? Do you think bots existed back then? Aha. Anybody recognizes this? This is Eliza. This is the one of the first, I would call them prototype of contemporary chatbots. I remember the first time I saw it, I spent like a week talking to it. And it was limited vocabulary. It was very limited amount of code. They did very, very credible simulation of human psychologist. I mean, it asked me, always asked me about my mother, but hey. Then, of course, came the internet. And the internet introduced its own issues and opportunities. That you could be whoever you want on the internet and nobody would know any better. And as, of course, is natural for us human beings, we evolved, our tools evolved, came social network. And now, the same two dogs have completely different things to worry about. Right? How many friends, followers, and so on they have. And of course, in any ecosystem, predators and parasites evolve, and now we have bots. And by some counts, oh, sorry that the slide is maybe a little bit too small. I was actually fairly certain that I would be the main speaker there and the screen is bigger. By some estimates, the amount of traffic in social media networks generated by bots is already higher than what we humans do. So they have already taken over. We still have a sizable foothold. So we need to figure out how to protect it. Not all bots are bad, and there are great many entities that can fall under the general definition of bots. Google crawler, in a way, is a bot, a robot, right? There are chatbots, there are scrapers, there are monitors that sit somewhere and tell you something bad happens or something good happens. Many, many, many variants. My talk will focus on Twitter because that's where our projects on bot detection focused. Twitter is a great platform for many types of research. A lot of data, very frequently updated, and very friendly API. I would love to do similar things on Facebook, but I don't know really how many loops you have to jump through to get the same access to data on Facebook. So estimates again vary. This is an official number from Twitter. In 2014, somewhere between 8 and 9% of accounts were bots. They generated disproportionately large portion of traffic, and of course, Twitter selling ads. If they don't know how many bots are there, or if bots take over a significant part of the feed, that's for them lost revenue. So some bots are actually good. There are information bots, there are news bots, there are bots that answer to your questions, like chat bots, there are service bots. We're about to begin a very interesting project where we were asked to create an anti-bot bot. So basically a bot that sits on a communication channel and listens, and most of the time it's completely transparent. But if it detects a bot-like activity, it takes over and takes certain countermeasures to try to stop the other guy, or at least find out who he is and what he wants. So some bots, as I mentioned, are not bad, not good. So phishing, obviously, influence amplification, and I will talk mostly about influence bots. So, very simple definition: programmatically controlled social media accounts created to promote or oppose a well-defined agenda. And they, over the last several years, have received a lot of press. And of course, everybody knows about US elections and British elections and Brexit, and bots have become very prominent. So, in many ways, bots have become a little bit even more human than humans, especially on Twitter, where the average Twitter user at least presents him or herself about this level. It's not very difficult to become more human than this. But still, bots are not human. They are programs. Programs are very smart, but there are limits to what they can do. So the assumption is that there are patterns that can be detected that differentiate between bots and humans. As you may have figured from the name of my company, Sentimetrics, we started as a sentiment analysis company. For a while, for several years, that was all we did. NLP focused on tracking and quantification of opinions expressed in textual media everywhere. So what did we have? We had sentiment analysis as a tool, and we had, to some degree, the ability to analyze the network. So we started with the tools that we had. There are other methods, and some of them are good, some of them are bad, most of them are academic. We needed a more practical application for our client. So we used some of the knowledge and some of the experience from previous systems, but we started to work on ours, on our own way to package the components and do the analysis. Bots are really getting sophisticated. It's not as easy nowadays to write a new bot, because first of all, users have become smarter. Second, because there are actually some bot detection components out there. Our system, Sentimetrics, I think it's a great name, so because we could start whatever we want with Senti and then add something else, so SentiBot. We have developed the methodology and kind of build a tool that we gave to our client, which in this case was Department of Defense. Did it in several stages. The current version is 2.0, but we didn't get there immediately. We started with a relatively simple version that focused on, as I mentioned, on the technologies that we had, sentiment and network analysis. And for a variety of reasons, our data set was Indian elections. I mean, I understand that very few people today worry about the Indian election of 2014. Probably even in 2014, people outside of India didn't really care much about it. But there are a lot of Twitter users in India. They are, to a very large degree, proficient in English. And there are a lot of actors. There are so many political parties and politicians in India. They probably about the same amount as in the rest of the world combined. So it was relatively easy to get to collect a fairly large set. We started in about mid-July 2013, and it went on for about a year. We collected, these numbers are a bit misleading. We collected about 500 million tweets, but then we started filtering. We wanted to get the tweets where there was enough content in English to be useful. So when all is said and done, we had 25 million tweets. We extracted the network, friend-follow network from Twitter, not complete network, because unfortunately, Twitter API has its limitation, imposes some restrictions. So by the time you collect a complete network on however small subset of Twitter users, it probably has already changed. So we were limiting ourselves to 2 hubs. So user, friends and followers of that user. Sentiment extraction. As I said, we started a sentiment analysis company, so we had our sentiment engine. And our sentiment score goes on a continuous scale from -1, which is really negative toward some topic. I hate this guy, to +1, which is absolutely in love. In all my experience with the company, I've seen +1 once. So it's a fairly restrictive score. In theory, it could happen, though. So, given the users who tweeted about topic of interest, we collected the followers and the friends of that user, and got a 45 million edge network. Also, we collected some statistics that are common in Twitter analysis: number of friends and followers, and the ratio of friends to followers. Now, we got into more interesting stuff. So our hypothesis was that some characteristics of the Twitter feed are more important than others. So we started with what we thought would be interesting. So number of hashtags, number of mentions, number of links in the tweet. Are they different between humans and bots? Tweet semantics. Are bots actually more prone to express strong opinions than people or not? And then tweet frequency. Obviously, if somebody posts 10 tweets a second for 10 hours a day, probably not a human. Right? If somebody tweets from, within an hour from 2 geographic points that are 1,500 kilometers apart, probably someone is playing with IP addresses. Sentiment. Do bots change opinions more often? Flip-flop is the term. Do they have more variance in the strengths of the sentiment that they express? And then we looked at some neighborhood characteristics, and we'll go through them a little bit later. Actually, here. So just a couple of examples. Contradiction rank. So there is a formula which probably is very hard to read from the back, but basically the contradiction rank is our attempt to quantify how often a particular user on a particular topic disagrees with either the Twitterverse globally, or we could have a more local version, kind of immediate neighborhood, how often he disagrees with his friends and followers. Agreement rank can be defined obviously similarly. Dissonance rank is the variable that basically just expresses the ratio between disagreement ranks across all topics. Positive and negative sentiment strengths, as I mentioned, we wanted to see if there is a difference between humans and bots. Okay, this one I already mentioned. Now, so overall, we actually ended up with about 140 variables. And some of them were sentiment related, some of them were not sentiment related. This just shows you the solid line is ROC of when sentiment is taken into account, just to demonstrate that sentiment actually does have sentiment related variables, does allow us increased accuracy in distinguishing between bots and humans. Top 25 most important features out of 140 that we had. The black ones are sentiment related, the dotted ones are not. And I know that you cannot read it from here, but just visually you can see that a lot of sentiment variables made it into top 25. So questions that we were trying to answer was, do bots or human flip-flop more? Whose positive opinions are stronger or negative opinions? Who tend to write more tweets that actually do express sentiment rather than just, for example, retweeting a link? And who tends to disagree with his neighbors or with the whole population more? Okay, so on the left there, sentiment flip-flop. Here's the results that we discovered when studying Indian election data. Bots here are the dotted ones, and they seem to flip-flop significantly less than humans. So a bot is created, or at least at that time, that's what the bots were created to do, with a particular opinion, and they went with it. Positive and negative sentiment strengths. As you can see, bots are far less likely to express strong opinions. They're all kind of clustered here to the left. Why, we don't quite know. I suspect that's so that people actually don't reject him outright. Because if somebody comes in and says, you would immediately, you would be more likely to disregard someone's opinion. Dissonance rank. And by the way, sorry, there is a typo in the caption here. Dissonance rank, bots tend to disagree with their neighborhood much more. And this one is very interesting. The fraction of tweets with sentiment. Bots either don't express any sentiment or they express a lot. There is pretty much no middle ground. Humans are far less polar. They tend to sit in the middle. Okay, now we're getting to the second stage of the project. So we learned all this wonderful stuff about the Indian election and bots. And then DARPA, Defense Advanced Research Defense Advanced Research Project Agency, came along and says, okay, we are going to run a bot detection competition. And the conditions imposed were actually very strict. So they got somehow an agreement to take the real Twitter data and inject bots in it. So they would recreate a tweet feed for us. They would give us 4 weeks of data initially, and then 4 weeks they will do essentially a real-time Twitter feed. The goal was to identify all the bots in this data that satisfied two conditions. This has to be influence bots, not spam bots. And they had to be the influence bots that were trying to push a message that vaccination is good. As you may know, in the US, there are groups of people who are anti-vaccination. And I guess the reason they chose this topic is that it's fairly obscure, and it doesn't have anything to do with politics. And the rules for determining the winner, for scoring the competition, were like this. You get 1 point for each correct guess. So you say account X is a bot. Correct, you get a point. Wrong, you get 1 point of a 1/4 of a point subtracted from you. And if you get, and we didn't know how many bots there were, but if we guessed all the bots, we would get an extra point for every day remaining to the end of competition. But if we would keep on guessing, we obviously would more than burn these bonus points by making incorrect guesses, because there aren't any more bots. There was no training data, right? They basically, prior to day 1, we didn't have anything, right? And obviously, they wouldn't tell us who the bots are. So we didn't have anything to base our assumption on. So it is a human in the loop system, at least initially. We wanted to go over this process. Classify accounts as bot versus not bots, then find the influence bots, then separate the bots that were concerned with the competition topic, and then find the positive versus negative bots out of that subset. This is the general architecture, and things circled in yellow there is essentially the part from Sentibot 1 that's having to do with sentiment. We sat together and tried to come up with bot classification of some sort. What looking at the data that we had after at day one, we saw that there were some bots that were ELIZA-like. They would repeat a certain portion of somebody's tweet and then add a question or add an opinion. There were subversion bots, infiltration bots, and we wanted to look at the flip-flops as well. We'll go through this in a little bit more detail later on. Once we had the initial set, we would be able to apply just classic machine learning techniques. But initially, we didn't have anything to base that, to train on for that. So we had several hypotheses that we were that we went with into the competition. The first one didn't have anything to do with the content of the tweet, but actually was looking at the profiles. We noticed that missing images, you know, that Twitter egg, humans tended to be a little bit more proprietary about their Twitter accounts, so they would put their picture more often than bots. Common naming patterns. Algorithmically created names, probably easier to create when you say Vadim Kagan 1, Vadim Kagan 2. By the way, those are not bots. Vadim Kagan 1 and 2, it's me. Bots, again, it was a hypothesis, would follow other bots to increase their number of followers. Because, you know, okay, I'm a young bot just starting out. This guy has been around for 2 days. He has already 15,000 followers. Let me follow him, say something nice, and maybe they will follow me. That's what we thought would happen. No, they don't do that. There are some similarities with the number of followers, but that was, I mean, these numbers are particular to the competition. In general, as we learned since, bots created with a common purpose or by the same creator, so to say, tend to have very similar number of users, friends, followers, sorry. And then incomplete profiles kind of go back to the profile images. Apparently, bot creators don't really pay that much attention to fully filling out the profile. Maybe after reading this, they will. I don't know. Okay, so we started playing with this, and we're creating a number of interim dashboards to allow ourselves to look at the data. And as you can see, but it's not working, you can see a couple of eggs there on the left. They're actually bot accounts. It's evolved over time. So this is one of the profiles with time-lapsed profile pictures. So they actually do change. So initial bot is created, and then iteratively they add on to the profile. What is this? Oh, this is the number of friends, right? So bots, up until they reach a certain popularity, tend to have a fairly flat friends count, and then sometimes they take off. Tweet distribution. As I said, if somebody tweets 24/7, probably not a human, although some of my friends do that. Bots, apparently, people who write bots are already smart enough to recognize that this would be suspicious. So this didn't happen as much as we expected. We didn't see many accounts that would just tweet nonstop. Again, we put it in a dashboard so we could check on the data manually in the initial stages. Flip-flops. If you remember from the Indian bot competition, there was we had certain expectations for the number of flip-flops that bots would do. Very few bots changed their opinion in the Indian election. Here, it actually was a little bit different. There were a number of bots that would try to sneak in. So if you are pro-vaccination bot, one good way to actually do your job is to start with an anti-vaccination sentiment. And then when anti-vaccination people actually accept you, then you switch. That's the kind of part of the infiltration. So, and we observed that it's actually really interesting. You know, bots interacting with real people, and then as soon as they click, yep, add as a friend, and enough people do that, it would not overnight, but fairly rapidly, the sentiment would switch to opposite. ELISA bots, these are my favorite. You could read them forever. Probably because the population of bots that we were dealing with here was created by a fairly limited number of programmers. There weren't really that many phrases in the seed set. We counted 53. And very often we would say, really, and then a link to something. Or love your opinions, and then a couple of other terms. Whereas the evidence was by far the most popular. I think that has to do with the topic. So you think vaccine work? Where is the evidence? Show me the evidence. And then you could go into discussion, and it's very easy to start, blindly refuting whatever evidence is put against you. We believed that no one would just write one bot. That's counterproductive. You write a bot, you tweet a few knobs, and you do a dozen, right? Or as we learned, 5 or more. So we started trying to find clusters of bots. This is a good one. So subversion. You give a message, and then you put a link that points to something completely different. So you say, vaccines are bad. And then you put a link to a site talking about how useful and helpful vaccines are, with the idea that somebody reads the message. Okay, let me learn more. Now let's go through the competition. So, as you remember, correct guesses would give you a point. Wrong guesses would subtract a quarter of a point. There were 12 teams participating, from very large companies to very small companies, from academic institutions of different sizes and pedigree. On week 1, no one made any guesses. People were still trying to digest the guesses. We had 4 weeks, all told. We were no different. We were doing the initial analysis. On day 2, we identified, we guessed, and it was more of a guess at that point. 2 bots that were using very short vaccine, good, vaccine, bad, very short combinations, and used similarity metrics to find 2 more bots. So we now had 4. We didn't know how many total bots there were. So at this point, we started having discussion. Maybe there aren't anymore. But then we convinced ourselves that this wouldn't be interesting, and DARPA wouldn't be spending all that money to just have 4. Okay, day 10. We found 4 clusters of similar bots, and started running DB-scan on their friends and followers to see if we could find, for example, similarly named bots. We found 4 clusters, and by the end of day 12, we had 29 bots. We still didn't know how many bots there were, but remember, 4 weeks, right? So we had 16 more days. And this is where we had arguments daily. Should we stop and say, yes, this is it? We didn't know how many other teams, how other teams were doing. We were only getting feedback on our guesses. Okay, days 11, 14. So we had 29 bots. We didn't have anything that was manually obvious to be a bot. So we started using traditional machine learning algorithms. Random forest was the most helpful. We added some new features, and we found another 10 bots. The slide said remaining. We didn't know at the time, right? So as it turned out, there were actually 39 bots. We still had 14 more days to go. And you know how hard it is to not do anything when you have like 2 weeks and you don't know if you are there? Okay, we made one more guess after that. I think on day 15. It was wrong. So it was our one and only mistake. After that, kind of the cooler heads prevailed. We don't have any evidence looking at the accounts, at the tweets, that there are actually bots. So let's not try to invent entities without the need for that. So when the competition came to an end, it turns out that we actually won the competition against, and this is what something I'm proud of, against IBM. Every time I meet with them, I tell them, you know, guys, Watson, Schmatson. I used to, it was my dream to work at IBM at some point. I guess now they will never take me after. But still, we did fairly well. So we had now this collection of tools that were built over 4-week periods plus the previous experience from Indian election data. And we wanted to productize it. We wanted to have a system that we could deliver to a client. This was 2015, so we had 2 years between then and now to do something with it. And the result is called Sentibot 2.0, which worked with a human in the loop. Follow these 3 steps. Find a few initial bot, try to do clustering, and then you basically do the machine learning. I'll show you some screenshots just to illustrate how we're going around it. So there is a main screen that gives you kind of overall statistics for the projects that you are interested in. So how many tweets you collected, what the time distribution is, the standard word cloud stuff. And then it shows you the number of Twitter users that are in the set, the number of suspected bots, the number of bots. Then we have a couple of other categories. For example, activists. And it turned out that news services are very, very much bot-like. They tweet often. They select controversial topics. And believe it or not, they actually do change opinion. Yeah. So the same BBC could publish an article being pro-Brexit, and then 2 days later, the same Twitter account would say something completely anti. By the way, BBC. So as I was flying here, we flew from Maryland, from Washington, D.C., to London, and then to Kiev. We landed in London, we had a brief layover, and I got an email from one of my partners saying, BBC has just, on September 12th, published an article about Russian bots that are following, I think, 2 of the heuristics that we suspected were bot-like in the DARPA competition. So if whoever is looking for Russian bots hired us, we would immediately recognize that. We would have immediately recognized that. Too late for that now, but okay. So by the way, I covered the Twitter names just because I was advised that it may not necessarily be 100% legally advisable to show the names and say, oh, this is a bot, especially if you're mistaken. So I covered the names. So the tool allows you to compare the values for multiple features. As you remember, there were about 140, so it actually continues fairly far down that side of the screen. And it allows you to compare this between this particular user, perfect. Particular user, suspected bots, confirmed bots, activists, and the like. You could look at the profile to see if that incomplete profile, partial stock image thing apply. You could look at their individual tweets if you want to. If you are an analyst, you may have some ideas of who would be a bot for you. So you could examine their behavior. Sorry. And then you could, what is this one? This one shows you all the relevant authors and the labels currently assigned by the system. Are they adversarial bots? Are they activists? Are they suspected bots? So on and so forth. So I think bots are here to stay. Both in that room and in this room, we heard a lot about artificial intelligence coming into force. We need tools to be able to detect them, not necessarily even to kill them, but to counteract them. If we know that a bot is spreading a certain message, or rather, if we know that a certain message is spread by a bot, we as human beings probably would be able to look at it more critically. Is our system perfect? Probably not yet. It's getting there. We started with, I think, 7 heuristics that we were, the system would automatically look for. Now we're up to 12. And as I said, proof is in the pudding. We actually beat IBM. This is it, I think.
Thank you, Vadim.